This is Advanced Algebra, Lesson 8-7, Powers and Roots of Negative Numbers. To begin the lesson, I want to start talking about integer powers of negative numbers. Now, we studied these quite extensively in Chapter 7, and I just want you to recall that all the properties of integer powers of positive bases that you studied in Chapter 7 also apply to integer powers of negative bases. Just take an example here, y equals a negative 6 raised to the power of x. Just look at some things that happen. When I take that negative 6 to the power of 2, I end up with 36. Negative 6 to the power of 4, I end up with 1296. Notice that my negative number now becomes positive when my exponent is even. Look over here, when I look at negative 6 raised to the third power, I get negative 216. Negative 6 to the fifth power, I get negative 776. So when I'm taking a negative number to an odd power, my answer is negative. Another thing I want you to remember is that when I'm taking a negative base to my power, I still need to follow order of operations. So a negative 6 to the power of 4 is going to be a negative 1296, whereas a negative 6 to the power of 4 is a positive 1296 because we have to follow order of operation. Here we have to take the negative 6 4 times, and here we take 6 to the fourth power, and then we have the negative. Let's try one more example using these, working with negative bases. Here I have negative 5 to the negative fourth power and negative 5 times negative 5 to the seventh power. That we can use our same product of powers postulate that we worked with in Chapter 7. So we can take our exponents and add them. So we have negative 4 plus our 7. So that becomes negative 4 plus 7 is going to be 3. So that leaves us with negative 5 to the third power. And we know that a negative value to an odd power is going to give me a negative number, and that's going to give us 125. The next part of this lesson addresses the question, are there non-integer powers of negative numbers? Let's take a look at some things that we have explored. We have explored the square root of negative 4. We know that that's 2i. We've also explored some various rules. We know that the square root of negative 4 times the square root of negative 4 is not equal to 16. We have to treat it special because of the complex piece or the pure imaginary number. So 2i times 2i equals negative 4, so these two are clearly not the same. And there were some other things that came about in your text. Taking a negative 2 to the power of 3 was not the same as taking the square root of a negative 2 to the sixth, because a negative 2 to the third equaled a negative 8, and the negative 2 to the sixth equaled the square root of 64, which equals 8, so these were not the same. So there are situations in which the powers and the roots of negative numbers have to be dealt with very carefully. So as stated in your textbook on page 557, it says, for this reason we do not define x to the power of n when x is negative and m is not an integer. So reading here, non-integer powers of negative numbers are not defined in this book. You will encounter those in other courses, but it's not defined in this textbook. We're going to next look at how to evaluate nth roots when x is negative and n is odd. So if we know that x is greater than 0, then the nth root of x stands for the unique, non-negative, real nth root of x. For example, the third root of 8 is equal to 2 and not negative 2. Let's take a look at the definition of the nth root of x when x is less than 0. So when x is negative and n is an odd integer greater than 2, then the nth root of x stands for the only real nth root of x. For instance, if we take the third root of a negative 8, that equals a negative 2 because a negative 2 to the power of 3 equals negative 8. Let's evaluate that with the fifth root of negative 32. We know that the fifth root of negative 32 is equal to a negative 2. If we check it, we know that a negative 2 to the fifth power equals a negative 32. We can explore that with a graph as well. If I were to graph x to the fifth equals negative 32, I know I would get a graph like this, and if I put a horizontal line through negative 32, my intersect point would be negative 2, negative 32. Now let's evaluate the nth root of x when x is negative and n is even. The nth root of x is not defined when x is negative and n is an even integer greater than 2. Therefore, the fourth root of a negative 16 is undefined. There are no real fourth roots of negative 16. We leave that undefined. Let's evaluate one more theorem here, the nth root of a product theorem. So when the nth root of x and the nth root of y are defined and are real numbers, then the nth root of xy is also defined, and the nth root of xy equals the nth root of x times the nth root of y. We're going to explore this more with the examples below. We're going to simplify the third root of a negative 1,250, and we're going to leave it in radical form. If I look at this, I see that I could write this as the third root of a negative 125 times the third root of 10. Now I chose that because this is a nice easy answer here. Third root of a negative 125 is a negative 5. And then I combine it with the third root of 10. Now I can't simplify that, so I will just leave it as a negative 5 times the third root of 10. To end this lesson, I would like you to try two more examples that I've added. So you'll want to add this to the bottom of your notes for 8-7. So I want you to try and simplify the third root of a negative 27 times x to the 12th and the sixth root of a negative 64. Try those. We'll discuss those in class when you return next time. This concludes lesson 8-7.